Alright, this is the first recording for this chapter, force. Alright, so first we'll discuss motion of different types. We have already gone through motions of different types. So this is a rectilinear motion or a straight line motion. Okay, this is a curvilinear motion, oscillatory motion, vibratory motion. This is a circular motion and a rotatory motion. Alright, okay. So we'll discuss two types of motion. One is linear motion, the other one is rotatory motion. Linear motion is when a body is free to move. Okay, if a body is free to move, it always goes in a straight line. Whenever force is applied, it moves in a straight line. So for example, this ball over here, okay, when a force has been applied in this direction, it will go in a straight line in this direction. If a force is applied in this direction, it will go in a straight line in this direction. So when a body is free to move, it performs a straight line motion. When a body is pivoted, that means it is fixed at some point, it will perform a rotational motion. It will rotate. For example, a globe or a world map that you see on a table sometime, earth. So this is a depiction of an earth, okay, in a spherical form, and when you apply a force on this, it goes around, okay, it rotates above this axis, all right, because it has been pivoted over here. So a linear motion is performed when a body is free to move. It will move in a straight line. A rotational motion is performed when a body is pivoted. It will perform a rotational motion. Alright, so factors affecting torque or turning of a body. So what are the factors that will affect turning of a body? So one, so say for example, this is a body which has been pivoted over here. Okay, at this point, so take a stone for example, and there is a hole that has been made over here, and there is a spoke that passes through it. Okay, now when you apply a force, okay, if you apply a force in this direction, it will move in a clockwise direction, and if you apply a force in the opposite direction, it will move in an anti-clockwise direction. So what is the factor that is affecting it? So one is the force that is affecting. So the magnitude of force, how much force you are applying. If you apply more force, it will spin faster, or more torque will be generated, more spin or more force will be generated over here. Okay. Second is the distance, a perpendicular distance from where you are applying the force. So since you are applying a force over here, this will be the line of action of force. That means the force is passing through this line. Say for example, if you are applying force over here, this would be your line of action of force. Now your line of action of force and the distance where the object has been pivoted. Okay, so perpendicular distance from there, that is called, this distance is a second factor on which the torque is dependent. So perpendicular distance from the force from the pivoted point. So where the point has been pivoted from and where you are applying the force. That has been seen. The more the length is, the greater is the torque that has been generated. Okay, so more torque is generated if the distance is more. Say for example, if you are applying force over here, distance would be small. In that case, this distance is very small over here, so you'll have to apply more force to generate the turning effect, right? And so from these two things we can say that magnitude of force, okay, and distance. So the torque, we can say the formula for torque is force into distance. Okay, it is nothing but force into distance. Now what will be the unit for torque? So torque is, we know, just now we saw torque is nothing but force into perpendicular distance. Okay, so force is given in Newton. Okay, the unit of force is Newton, and that of perpendicular distance is meter, or distance is meter. So together it will give us Newton meter, and the CGS unit for it is dyne centimeter. Okay, so this is one of the units. We'll be studying about one more unit for torque in another video. Okay, thank you so much. Bye.